Good morning, student. Let's start today's class. Okay. In today's class, we are going to discuss about the types of error detection techniques. Okay. The the error in the receiver frames are detected by means of parity check. Okay, and cyclic redundant check. Okay, these two methods are used for error detection at the receiver end. In both cases, few extra bits are sent along with actual data to confirm that bits received at other end are same as they were sent. If the if the counter check at receiver end fails, the bit are considered corrupted. Okay. In the both cases, that is parity check and cyclic redundant check, we send some extra bit or few extra bit with the information or with the data to ensuring that we can get the data at the receiver. We can get the same data which we will send and at the receiver end. Okay. Now let us see what is parity check system or technique. One extra bit is sent along with the original bits to make number of ones either even in the case of even parity and in odd in the case of odd parity. That means here in parity check what happened, there are two types of parity check or two types of parity. Okay, one is even parity, one is odd parity. In even parity what happened, and in parity check one bit, okay, one extra bit is sent along with the original bit. Okay, and to make the number of 1s either even in case of or odd. Okay, that means one bit, okay, is if in even parity, let's say in even parity what happened, if we want to send this much of data to receiver end, so uh, so in even parity, first of all we count the number of ones. Here 1 2 3, three number of ones is there. Since it is even parity, since it's even parity, we want even number of ones. Okay, here but here one number of ones is odd. Okay, so we add 1. Okay, so we add 1. That means our now our bit, our information is 1 0 1 1 and extra bit which is 1. Now our even parity is done. That means 1 2 3 and 4. Four number of 1 is there, that is even number of 1 is there. Okay, and again if odd parity are there, okay, if we want to send this much of this, again this that much of uh, signal, or this is the digital data we want to send, and in the odd parity, that if here the number of 1 is odd, so in odd parity we want odd number of 1, so we add 1 0 1 0 1 and 1 0, we add 1 0 here to make the number of 1 odd. Okay, since the number of 1 is the number of 1 is odd here, so we add 0. If the number of 1 is even here, then we add 1 to make that number of 1 is odd. Okay. Next, the sender, while creating a frame, okay, count the number of 1s in it. For example, if in even parity is used and the number of 1s is even, then one bit with value 0 is added. That means if here you see, this is the data we want to send, okay, and it is even parity. Okay, here one number of 1 is 1, 2 and 3, so 3 number of 1 is there, so it is in odd number. So we so to convert that odd 1 into even 1, we add extra 1 bit. Okay, extra 1 bit here. Okay, to make that number of ones or even. Okay, since it is an even parity. So similarly, if there is the even number of 1 is there, okay, let's say 1 is there, that is 4 number of 1 is there, then what happened, due to since there is already the even number of 1 is there, so we add only 1 0. Okay, we don't add any 1, we add 0 in the place of 1 there to continue the even number of 1 in the data or frame or data unit or frame. Okay, this why number of 1 is remain even if the number of 1 is odd. To make it even, a bit with value 1 is added or added. That means our aim is to in even parity by anyhow we want number of 1 is even. Okay, and by odd in odd parity we want number of 1 in odd. Okay, and see the process of even parity. This is the process of even parity. Sender, this send the digital signal. First compute parity bit. Okay, first counting the parity bit. Okay, and see that it is in odd number of 1. Okay, and so that it add uh, one one bit. Okay, and then transmission media transmit them, and here in receiver end this is received, and again count the bit, count the parity bit. Okay, and see and count the parity bit, and if the number of 1 is even, okay, yes, then accept the data, then data is accepted at receiver end. If the number of 1 is not even, no, then data is rejected, did not receive the receiver or receive the data. Okay, this is the process behind even parity process. Okay, here the receiver simple count the number of 1s in the frame. If the count of 1s is even and even parity is used, then frame is considered as a non-corrupted. Okay, or there is no error, and is accepted. Okay, if the count of 1s is odd and odd parity is used, then the frame is still not corrupted. That means there is no error. Okay, if a single bit flips in transit, the receiver can detect it by counting the number of 1s, but but more than one bit are erroneous. If more than one bit, but if more than one bit are erroneous, then it is very hard for the receiver to detect the error. That means parity, in parity check we can check the error for 1 bit. If there is an error of 1 bit, that means in previous classes we see the types of error. One is single bit error, okay, another is burst error. For single bit error, the error is detected by parity check, but in the burst error or multi error, the parity check cannot check the or detect the error on at the receiver end, okay. And next, how can we detect that parity or that burst error by any techniques, or by any techniques? That techniques we can read or we can study about in coming classes, okay. Thank you.